So after getting the Laplace transform of the function and manipulating using algebra, we need to get the inverse Laplace transform, or we need to transform the function back to time domain. So when fraction is involved, there are three possible forms. So this is with the use of partial fractions. So we have simple poles, so this form. We have repeated poles, and then we have complex poles. So for example, find the inverse Laplace transform of the following. So using the partial fraction method, we have a over s plus b over s plus 3 plus c over s plus 1 plus d over s plus 1 squared. Now we can get the values for a, b, c, and d using two methods. So the first method, you can form a series of linear equations, then solve for a, b, c, and d, or we can assign values to s and then solve for a, b, c, and d. So let's use the second method. So first, let's multiply the equation by this denominator here. So this equation becomes s cubed plus 2s plus 6 equal to a times s plus 1 squared times s plus 3 plus b times s plus 1 squared plus ds times s plus 1 times s plus 3 and plus ds s plus 3. Now if we let s be 0, so looking at this side right here, we let s be equal to 0, so this term, and this term will be 0. So we are left with, we have 0 plus 6 equal to a times 0 plus 1 squared times 0 plus 3. We have a equal to 2. So next, if we assign s as negative 3, so our equation becomes, we have negative 27 minus 6 plus 6 equal to, so a, the terms with a, c, and d are 0. So we only have negative 3 b times 4. So b is equivalent to 2.25. Now if we let s be equal to negative 1, so the equation becomes, we have negative 1 minus 2 plus 6 equal to, so the terms with a, b, and c will be 0, and we're left with negative d times 2. So d is equivalent to negative 1.5. Now last, to solve for c, if we let s be equal to 1. So the terms a, b, c, and d will not be cancelled, but we already have the values for a, b, and d. We can plug in the values for a, b, and d. So we have 1 plus 2 plus 6 equal to 2 times 4 times 4 plus 2.25 times 4 plus c times 2 times 4 minus 1.5 times 4. Solving for c, we have negative 3.25. For this equation, we have now 2 over s plus 2.25 over s plus 3 minus 3.25 over s plus 1 minus 1.5 over s plus 1 squared. Now getting the inverse Laplace of this equation, we have 2 u of t plus 2.25 e to the negative 3t u of t minus 3.25 e to the negative t u of t minus 1.5 t e to the negative t u of t. Or we write this as 2 plus 2.25 e to the negative 3t minus 3.25 e to the negative t minus 1.5 t e to the negative t times u of t.